We're now going to look at OSPF areas. OSPF has this concept of areas. All networks must have an area 0, which is the default area. And areas are used to scale OSPF for really large networks. There are many types of areas to suit the many different types of infrastructure and topologies. Most mid-sized networks today can easily operate with over 300 routers in a single area. And in fact, most network operators operate their networks only with area 0. OSPF now supports IPv6, but in a slightly different way from ISIS, which we'll see elsewhere in this series. OSPF version 2 is developed for IPv4 and has only been designed to carry IPv4 prefixes. For IPv6, OSPF was extended and is now called OSPF version 3, and it's only for carrying IPv6 prefixes. There is no support for IPv4 prefixes within OSPF v3. OSPF v3 is documented in RFC 5340 and works totally independently from OSPF v2. The configuration concepts and the syntax are very similar. There are subtle differences and improvements which are really beyond the scope of this presentation. There are two types of links in OSPF. One type is the point-to-point link, where there's only one other router on the link, forming a point-to-point adjacency. The other type of link is the multi-access network, for example, the Ethernet. There's a potential for many other routers to be on this network and with many other adjacencies. OSPF in multi-access networks has optimization to aid scaling. 2 routers are elected to originate the LSAs for the whole multi-access network. These 2 routers are called the designated router and backup designated router, respectively. Other routers in the multi-access network form adjacencies with the DR and the BDR. There is one designated router per multi-access network. It generates the network link advertisements, assists in the database synchronization, and lets us scale OSPF. And there's also one backup designated router. If you look at the diagram in the slide, you'll see an Ethernet LAN with one designated router and one backup designated router. The designated router is chosen according to configured priority, and that is set on the interface on the multi-access network. The highest priority router becomes the DR. The next highest priority becomes the BDR. If there's no priority set, or the priorities are left to the defaults, the priority is determined by the highest router ID. The router ID is a 32-bit integer. So the router ID can be set manually, otherwise it's derived from the loopback interface IPv4 address, otherwise, in the absence of a loopback, it's set from the highest IPv4 address on the router. Network operators really don't like this undeterministic way of setting the designated router. So they usually, if they're not using a loopback with an IPv4 address, they usually will configure the priority on the interface in question.